Multiplication means adding the same number to itself a specified number of times. For example, 2 times 7 is the instruction. Please add the number 7 to itself twice. So we happen to know that's 14, but that's a coincidence. And if you happen to see something like 3 plus 3 plus 3 plus 3 plus 3, so you see 1, 2, 3, 4, 5, please think about that as 5 times 3. So that was easy. If you know how to add, then in some sense you know everything there is to know about multiplication. However, we quickly run into exactly the same problem with multiplication as with addition. Recall that in addition, it is easy enough to add a couple of small numbers by counting on your fingers. The numbers do not have to get very big, however, before you have to start thinking about some clever ways to get the job done. Just the same with multiplication. 2 times 7, right, is a simple exercise in addition. 123 times 456 is an entirely different problem. Consider the following problem. 123 times 5. This problem is asking us to add the number 5 to itself 123 times. In other words, 5 plus 5 plus 5, and so on. 123 times. You're never going to do this. Not only would it take you all afternoon, but you're bound to make mistakes. So at the end, you'll probably have a worthless result. So we think and think and think, and then we get a bright idea. In other words, the question is, how are we going to do this? Well, you know that, I hope you know already that multiplication commutes. In other words, so you know that 2 times 7 means 7 plus 7 equals 14. As it happens, 7 times 2 equals 2 plus 2 plus 2 plus 2 plus 2 plus 2 plus 2, right? Did I get 1, 2, 3, 6, 7? And if you add those up, you get again 14. 2, 4, 6, 8, 10, 12, 14. So in the problem 123 times 5, adding 5 to itself 123 times, we decided is a pretty miserable job. Let's not do that. But how about 5 times 123? That's a little more interesting, because now what we're doing is adding 123 to itself 5 times. This is a little more malleable. Remember how we did this in the unit on addition. So I'm going to add 123 to itself. I'm going to do it. Remember, we expanded the number, so it's going to be 100 plus 20 plus 3 plus 100 plus 20 plus 3 plus 100, and so on. Let's organize this on paper. So the way we're going to say it is 100 plus 20 plus 3 plus 100 plus 20 plus 3 plus 100 plus 20 plus 3 plus 100 plus 20 plus, that's a plus here, right? One more time, plus 100 plus 20 plus 3. Now, before you start adding this up, notice this first. Here we're going to add 100 plus 100 plus 100 plus 100 plus 100, which I hope you recognize as 5 times 100. Plus 20, 20, 20, 20, 20. This is 5 times 20. Plus, you know what this is. This is 5 times 3. In other words, instead of one large multiplication, 5 times 123, we are multiplying in pieces. Just like we added in pieces before, we are now multiplying in pieces now. Essentially what we did, let me bring this up a bit. We said, let me write this another way. We said 5 times 123 We expanded the 123, 5 times 100 plus 20 plus 3, and we said 5 times 100 plus 5 times 20 plus 5 times 3. Probably you recognize this setup as the distributive. Sorry for my bad handwriting. It's the graphics tablet. This is the distributive property. And if you've ever wondered where does this distributive property come from, well, now you know. It is a natural, inevitable consequence of just adding things up. Again, this means that we take one relatively large multiplication, 5 times 123, and we break it up. We break up the number along the digits into 3 smaller multiplications, 5 times 100 plus 5 times 20 plus 5 times 3. And like before, let's just organize this on paper. So we have 100 plus 20 plus 3. We're multiplying by, this is multiplication, by 5. And so it's 5 times 3, 15. 5 times 20 is 100, and 5 times 100 is 500. And there's our 615, which is what you've been doing all along. When you multiply 123 times 5, you say 5 times 3 is 15. Like addition, there's our carry. Our carry comes from here. 5 times 2 is 10, plus 1 is 11. Put the 1, carry the 1. Here again is our carry. 5 times 1 is 5 plus 1, 6. So that's what you've been doing all along. That's all well and good when you have a single digit, right? So 5 times 7 is one thing. 5 times 123 is another thing. What do we do with something like 25 times 123? Well, we can fuss around a bit, but let's cut to the chase. The concept is easy enough. This is just more of the same. We're going to use the distributive property to break up the numbers into, in other words, to break up the one large multiplication into several smaller multiplications, except we're going to do that a couple of times. The idea is easy enough. It can be a little messy on paper, so let's go through this slowly and you will try it on your own. The key idea is to, in step 1, is to think of this guy as one number that we are distributing across, like this. In other words, we're going to have 25, we're thinking of it as one number, times 100 plus 20 plus 3. So this is 25 times 100 plus 25 times 20 plus 25 times 3. So we've taken the one large problem, 25 times 123. We now have 3 smaller multiplications. This time, but now we're going to go to step 2. This time, we're going to think of these digits, the 100, the 20, and the 3 as a single number, because remember, they represent, the 1, the 2, the 3, and we're going to distribute that number across the 25. So what we have now, let's think of it as the first multiplication is 100 times 20 plus 5. So that's 100 times 20 plus 100 times 5. Then we have, this is the first multiplication. Now this one, well, this is 20 times 20 plus 5. That's 20 plus 5 equals 20 times 20 plus 20 times 5. And finally, we're looking at this guy. This is going to be 3 times 20 plus 5. So this is 3 times 20 plus 3 times 5. We started with one large problem, 25 times 123. We broke that up into 3 smaller multiplications, and then we broke broke up each one of these into 2. So now we have, instead of the one large multiplication, we now have 1, 2, 3, 4, 5, 6 multiplications. Don't despair. It's simpler than you think. You just have to think about this for a bit, try a couple of simpler problems, because here is the pattern. Notice what we have here. We have 20 times 100. I'm actually working down this way. So I have 20 times 100 plus 20 times 20 plus 3 times 20. That's a 20. Plus, and then I'm going to work down this column, 5 times 100 plus 5 times 20 plus 5 times 3. You'll see in a moment why I kind of turn them around. So again, if you think about these for a minute or two, there's a very interesting pattern that comes out. The original problem was 25 times 123. Now let's expand each of these. This is now 20 plus 5 times 100 plus 20 plus 3. And this pattern here, look, I know it's messy, but you'll have to try it out you'll have to try it out for yourself. And you can see this pattern. What we've done is, what happens is that this first term multiplies each of the second terms. So it's 20 times 100 plus 20 times 20 plus 20 times 3 plus 5 times 100 plus 5 times 20 plus 5 times 3. That's what we see on this pattern. So each term in the first factor multiplies every term in the second factor. And that's what you've been doing all your life. You're saying 123 times 25. You're saying 5 times 3 and 5 times 2 and 5 times 1 and 2 times 3 and 2 times 2 and 2 times 1. And then, of course, because we're doing this, we're thinking of this as single digit, just like all that business when we did in addition, right? So the table takes care of positional value for us. Let me clear the decks and walk you through it. So the problem is 123 times 25. We're thinking of this as being in a number table. Right? This is the ones column, the tens column, hundreds column, thousands column. 5 times, so I'm beginning here, so this is my ones column. 5 times 3 is 15. I'm going to shift over 1, so this is the new ones column. 5 times 2 is 10. And then I'm shifting over, this is the ones column now. 5 times 1 is 5. So that's the first, this is the first, the result of multiplication by the first digit. Now the second one, here I'm starting with the 2. It's going to be 2 times 3 and 2 times 2 and 2 times 1. So I'm starting, this is now my ones column. This is my starting point. 2 times 3, 6. 2 times 2, 4, right? Because I'm shifting, right? We shifted over 1 position here. We're going to shift again. So this was my ones. This my ones now here. 2 times 1 is 2. So now let's see what happens. So we have here 5, 7, 5 plus 4, 9 plus 1 is 10. And now we're adding one more time. Here's our 3075. So 3075. Is that really how it works out? Well, of course, this really is how it works out. This is what we've all been doing, but let's do it the familiar way. 123 times 25. So just as we do here, this is each one of these digits multiplies every one of these digits. 5 times 3, 5 times 2, 5 times 1, 2 times 3, 2 times 2, 2 times 1. You know how that goes. 5 times 3 is 15. There's the 5 carry the 1, which is an addition, right after we do the multiplication. This is our carry here. I won't do that again. I'm just pointing it out to you. So 5 times 2 is 10 plus 1 is 11, but the 1 carried the 1. 5 times 1 is 5 plus 1 is 6. 2 times 3 is 6. 2 times 2 is 4. 2 times 1 is 2. 5, 7, 10. That, of course, belongs up here. 3075. And that is multiplication. So multiplication is just, you could say, wheels within wheels. That is, you distribute and then you distribute again. The distributive property is the multiplication algorithm.